Hey guys, welcome back to our channel Get Play Soon. In this video, we're going to see if the given two strings are anagrams of each other or not. Now first let's understand what is the question. What is meant by anagrams? Anagrams means all the possible permutations. Now anagrams of strings means all the possible permutations of the given string. In the right side you can see in the example, for the example string GPS, the anagrams are GPS, GSP, PGS, etc. So with the letter G we have two anagrams. With the letter starting with P we have two. With the letter starting with S we have two. Total we have six anagrams. So we have six permutations of the given string GPS. You can also notice anagrams, all the anagrams are of same length. This is the permutations, right? So everything will be of the same length. Now the question is, we have to check if the two strings are anagrams of each other. Now string 1 is GPS and string 2 is SPG. From the right side table, we can say that these two are anagrams of each other. Now let's see how to do this in programming. First, check the length. When you check the length, you can also know that these two strings are of same length. If these are same length, then continue. If it is not of same length, we can say these two are not anagrams of each other. Now these GPS and SPG are of length 3, so we move ahead. Now we will sort both the strings in the ascending order. GPS is already in ascending order. We will sort the string 2, that is SPG, in ascending order, that becomes GPS. Now compare the strings. After sorting both the strings in ascending order, we just compare. If both are equal, then they are anagrams. If they are not equal, return false. Let's first understand the code. In the main function, you can see we are passing two strings. One is GPS and the second string is SPG. Now we are passing these two strings to the check anagrams function. Now look at the check anagrams function. In the check anagrams function, it's a boolean function, which means it returns either true or false. So we are passing two strings, string 1 and string 2 here. Now the first step is we are checking the length of the strings. If both strings are of same length, then we will proceed. If they are not of same length, we then only understand these two strings are not anagrams of each other. Once we check if both strings are equal, then move, and if it is true, then we move ahead. Now, here we are sorting the given string. To sort the given string, I am sending the strings to the another function, that is sort string. In the sort string function, we are creating a character array and we are changing the string to characters, and then we are sorting with the characters, and again we return it as string. So we are passing string 1 and string 2 to this function sort string, and we are sorting the strings in the ascending order, and we'll get the strings from there. Once the strings are back, now we will check both the strings. Now if both the strings are equal, that means the given two strings are anagrams of each other. Now both strings are not equal, which means it is false. Now let's understand the time complexity. In the program, we are doing three main things. Number one, we are sorting the strings. Number two, we are checking the length of the strings. Number three, we are iterating in a for loop, right? So for sorting, it takes O of n log n. Okay, because that is sort string method in Java, it takes O of n log n. And for checking the length of the strings, it is O of 1. And for loop runs throughout the strings only once. And n is the length of the string. So O of 1 plus O of n log n plus O of n, removing all the unnecessary and small complexities, gives you O of n log n. So the time complexity is O of n log n. Now here we are not creating any extra space in our program. That's why the space complexity is O of 1. Now you can see that the time complexity is little high and we can reduce it. To reduce time complexity, let's get started with the another approach. In this approach, let's take a frequency array. The frequency array is the array for the characters. Now we have 26 alphabets. So take a normal single dimension array with 26. So 25. Index starts from 0. So take an array with the length 26. Now I have mentioned ABCD and these boxes for your clarity. So in this approach, we will create a frequency array for alphabets. We have 26 alphabets, so create an array with the length 26. Now for your understanding, I have made these boxes, don't worry about the boxes. Now we'll get started. By the way, initialize the array with zeros. Okay. Now we'll get started with the string 1. We have encountered yes in the string 1, so increment yes. Again, moving forward, we encountered p, so increment the value of p. So we have encountered g, increment the value at index g. Similarly, we go to string 2. So you can see we have three ones here. Now in the string 2, we encountered g, decrement g. 1 minus 1 becomes 0. Again, we decrement p, it becomes 0. We have yes left. So we have encountered yes and again it became 0. So finally we are left with all zeros. If we are left with all zeros, then we can say that the given two strings are anagrams of each other. Let me give you a small recap. Whenever we encountered a character in the string 1, increment the pointer count. Whenever you encountered the character in string 2, decrement. So by the end it should be all the count of the all the characters should be 0. If it is 0, it is anagram. If it is not 0, it is not anagram. So let's get started with the program. So let's get started with the main function. In the main function, we are passing two strings GPS and SPG, and we are passing to the function check anagrams. Look at the check anagrams function. It's a boolean function where it returns true if it is true, it returns false if it is false. We are passing two parameters, one is string 1 and the other is string 2. Okay. Now, what are we doing here? We are checking the length of the string. If both the strings are of same length, we can proceed further and check if it is anagrams or not. If the length is only different, then there only we can declare these are not anagrams of each other. Now, in the next statement, you can see that we are creating a frequency array with the length 26. Okay. By default, all the values will be stored as 0. Now we have three for loops here. Okay, you can see the three for loops. What are we doing? The first loop iterates over string 1, the second loop iterates over string 2, and the third loop does another thing. First, let's understand the first two loops. So what happens in the first two loops? We are subtracting character A from arbitrary character in the string 1 and string 2. Okay. When you subtract character A from the index pointer of that string, you will get the index of that letter. Okay. So the first two for loops, we are subtracting character A from an arbitrary character in the string. So what you will get? You will get the index of the letter. Okay. So for example, you encountered G. You will do character G minus character A. You get the index of G, and then you increment the index of G from 0 to 1 in the first for loop. In the second for loop, if you encountered character G, you will do character G minus character A. You will get the index of character G, and in that index you will decrement the count. In the third for loop, what we do is we check if all the values in the array are 0. If all the values in the array are 0, then it is anagram. If not, it is not anagram. This is how you find if the given two strings are anagrams or not anagrams of each other. Now, speaking about the time complexity, we are using three for loops, right? So, three of them are not nested. So, O of n plus O of n plus O of n, 3 O of n, removing the constants gives you O of n. Again, we are not creating any extra space, so the space complexity will be O of 1. I hope you understand the problem. I hope you understand the approach. In case you liked it, please like it, share it, and subscribe to this channel. Get this soon. Thank you so much.